Okay, forensic students, we're going to start talking about fibers and how they can be used in crime scene investigation. There is a forensic value to fibers found at a scene. They're almost always found at crime scenes. That is because they're easily transferred from one source to another. That's Locard's exchange principle. Every contact leaves a trace. But we have discussed in class already that fibers are considered class evidence. It is very difficult to narrow down hairs and fibers to one specific source. Because fibers are so common, it is very difficult to narrow them down. N- um, Fibers are usually good evidence because they remain in contact for years without degrading, but there is a time sensitive factor when you are collecting fibers. They don't stay in one place forever. Usually, after 24 hours, you're losing most of your fiber evidence. Fibers are characterized and classified by both chemical properties and physical properties, and we're going to observe both in the labs that we do in class. When you are investigating fibers, you only want to observe and collect fibers that you wouldn't expect to find at that crime scene. So if you find cashmere fibers on a person that has never worn cashmere in their life, that's probably something you would investigate. The greater number of fiber types that you find and the more unique the material, the greater the significance that value will be in the court system for those fibers. When we talk about fibers, we're going to talk about two types of fibers, natural and synthetic. Technically, synthetic can kind of be into chemically altered and synthetic, but we're just going to lump them into one. For natural fibers, these are ones that come from animal. They're produced by an animal. Wool, mohair, cashmere, angora, fox or mink fur, and then also silk from silkworms, produced from the cocoons of silkworms. They can also come from plants. The most common of these is cotton. You do need to write this down that cotton is the most common form of fibers. Then hemp, jute, flax, and bamboo. Then you have mineral, usually produced from something in the ground. Asbestos or fiberglass are natural types of fibers, and this is what they look under the microscope. So you have what they look at, like under the microscope, and also you have a cross section of it. Synthetic fibers usually are man made or chemically processed natural fibers. Most of them are petroleum based, so think plastic. Um, these are some of the more common types of synthetic fibers. You have polyester, which is the most common synthetic type of fiber. Rayon is kind of chemically processed and treated cotton, so it kind of goes into that chemically processed natural fiber form of synthetic. Then you have nylon, acrylic, acetate, and spandex. So when you look at these two fibers, this is natural cotton here, and this is rayon. And rayon is chemically processed cotton. So you can tell the difference between the two. The cotton has an irregular shape, while rayon and other synthetic fibers tend to be very smooth. We are going to be doing some testing to identify types of fibers. We are going to look at them under the microscope. So you really want to pay attention to the outline of the fiber. If it comes from an animal, it's going to have cuticle scales. But a synthetic fiber is going to be very, very smooth, very regular because it's manufactured. It's literally shot out of a tube. So it's going to be very smooth. We are going to do flame test or burning of fibers. We're going to look at how a fiber burns, the smell, the color of the flame, the smoke, the ash that's left over. And you can tell a difference between a synthetic and natural because natural fibers catch fire While synthetic fibers, they're basically just plastic, they melt. So, whenever you're welding or working around flames, you always kind of want to wear something like cotton. Yes, it catches on fire easily, but it burns up quick. Like polyester or any other synthetic will just melt to your skin. Thermal decomposition would be like melting. You can test to see the solubility of different fibers, especially the synthetic ones, and the decomposition of them. The density, refractive index is just how they've been light, and then the fluorescence. So if you add different wavelengths of light, do they turn different colors? We are going to be doing microscopic observation and burning of the fibers. We have talked already about how to collect fibers, but you want to bag items individually in paper bags. Usually, you don't want to use plastic because of static. You want to do tape lifts on skin areas or clothes. Individual fibers that are picked up, you want to put them in like a paper bundle and put them in a bag. Now, fibers have been in the news lately because many court cases have been overthrown, or guilty verdicts have been overthrown because fiber evidence was the main source of evidence. You can't use them as the sole evidence to convict a person in court. But fibers can connect a victim to a suspect or a suspect to a crime scene. They can help with reconstruction and movement of persons at a crime scene. They do have forensic value. We are not studying them just because they've always been studied. They do have forensic value. So we are going to look more into fibers. We're going to look at the Wayne Williams case study about a man convicted on solely basically on fibers and do some other labs. So let me know if you have any questions.